My name is Sean Martin, and I'm the CEO and Managing Director of a company by the name of ARKTREE, and we are in partnership with SYSPRO. Our role with SYSPRO is essentially to facilitate the application of blockchain and distributed ledger systems within the technology stack of the greater enterprise architecture. Today, we will be discussing the topic of automation and the evolution of automation. And so I'm going to kick over to a presentation now where we can get started. Deirdre, is there anything you needed to say before I get cracking?
Nothing from my end. Just looking forward to the discussion. Thanks, Sean.
Great, yeah, and let it be that. Let it be a discussion. So I'll go through this. There's a couple of videos, one with sound, and then two that will just demonstrate, the application. And what I want to do is introduce you to this high-level principle that, if we talk about automation, it's not your conventional. Everyone knows what automation is and what machines are and how they can do things automatically, but I want to just put a bit of a spin on that for us today, and that might facilitate discussion subsequently. So, ARKTREE and Shift are in very close alliance, and so this being a SYSPRO partnership, I felt the need to bring Shift into the picture because Shift is our agri-tech arm, and they do a lot of really cool agri-tech applications in the space of provenance and traceability across different agri-commodities, as well as digital auctions. So we provide them with a lot of the back-end technology, and they do a lot of the front-end application of that technology using RFID and handhelds and AI and whatever else. So that's their role. When we look at automation in its conventional sense, we know that it was essentially coined by D.S. Harder from GM, and he essentially defined it as the automatic handling of parts between production processes. In 1771, Richard Arkwright invented the first fully automated spinning mill. So this was the first time that the world saw this thing called automation in action, and he takes credit as the inventor thereof. And academically speaking, it's split up into three types of automation. Firstly, there's the fixed type of automation, which is essentially a machine that does exactly the same thing and cannot be altered. It will always do only that one thing. It then evolved a little bit into what was referred to as programmable automation. So here we could alter the state of the machine such that it could do more than one thing, typically for batch production. And so you could create smaller or larger batches or slight variants of the product by simply altering the machine, but you still had to physically alter the machine, and these exist today still, but that is referred to as programmable automation. And then you get an extension of that referred to as flexible automation, and this is where the machine is able to take instruction from a remote source, and often it is pre-configured with some form of intelligence that allows it to do Boolean logic and if-then-else type logic, like robotics in the automotive industry, where it will know that a specific model will require specific colors and sizes and features, and the very next model will be completely different, and it will be based on programmable results. So those are essentially the three different types of automation. If we come to the current time, we need to consider automation in the context of technology that we have today, and we've come very far. We look at things like smartphones and big data analytics and the Internet of Things and drone surveillance and artificial intelligence, machine learning, Elon Musk's Neuralink, bio and nanotechnology, virtual and augmented reality, this concept of virtual scarcity, which is driven by blockchain and the associated smart contracts. So these are all really great, let's call them inventions that facilitate the progression of automation in today's time. And my first sort of out there statement is, okay, so so what, right? So we've got all these different things, but what are they purposed for? What are we trying to achieve with these different elements that drive automation across our various supply chain landscapes? And things that people aspire toward, sustainable goals and aspirational goals that companies and people aspire toward, would be things like precision agriculture and carbon neutral sustainability, or solving the education inequality problem and poverty eradication and general global well-being, eliminating waste and irresponsible production or consumption, dealing with environment protection and even regenerative agriculture, i.e. trying to reverse the negative impacts of what we've done from the Industrial Revolution to date. And then, of course, automated sort of trustless, and I'll explain that concept shortly, governance, which allows for a society of peace, justice, and strong institutions. Trustlessness is the concept that comes with the idea that, of course, we all want trust, but we don't want to have to trust. We would like it to be a trustless environment. We don't need to trust because it is by design a trusted environment. And so we can trust that it is trustless. Taking this concept of automation, where we are now and the purpose of it, I want to jump across to some more tangible sort of. So first I want to pose a problem to you. I want to say, okay, we've got this globally connected world, and we've got all these devices, and they're all driving this kind of agenda of automation, but in a way they're competing with each other. And if you think of the idea of, if you go and buy an appliance at Dion or Macro or whatever, and you think of the fact that you go in there and you say, okay, I want a speaker, or I want an oven, or I want a fridge. Those are devices, and they've come from the Industrial Revolution. We've come a long way, and we can go and we can be pretty sure that if we buy that device, when we come home, we can plug it in and we can use it. It's not really the same in the world of all of this new technology. The standards of plugging in and playing with what we buy are still very federated and fragmented. And we find that this often results in a sort of a deterioration in efficiency and automation, because these devices are essentially competing with each other when really they could be collaborating with each other for an effect of synergy across the supply chain. So when you look at all these different agencies and policing officers and importers and banks and transporters and all these different actors in the supply chain, they are effectively limited by their inability to cooperate with each other, because sometimes they're competition, sometimes they're just at different levels of maturity, sometimes there are political or economic or social or technological or ecological or legal reasons why they can't really connect to each other. And so there are these sort of barriers to entry which limits their inclusion. Often inclusion is a financial or a resource-based thing, often it's a geographical thing. So if you think of very small companies that could be part of a supply chain, but because they're not really on the map and we can't track the quality of what they're doing, it's very difficult to say, let's incorporate them within the global supply chain. And so they've got perfect product that they could be distributing, but they're just not legitimate enough to participate, and so they aren't included. And even when you get that, when you can overcome those principles, there's still the issue of privacy and transparency, because now we're talking about collaborating with our competition, which is this new principle called co-opetition. And so we need to find a way to overcome these challenges so that we can all trust each other and carry on doing what we're used to doing without the risk of losing our competitive advantage or being put out of business. And this is essentially the challenge that I want to pose to you now. Now, in the textiles industry, this idea of value chain linkages comes across, where this problem is starting to be solved. And I want to play a video for you, and then I want to give you another example in livestock. Thereafter, I'm gonna take you back to this principle of automation and what it's evolving to and how it fits into what I'm discussing here. So I'm going to play a video. If you guys can't hear, please shout at the top of your lungs and I will address the problem, but I think you will hear, hopefully. Let's see.
I'm Jaco Maas. I'm the General Manager of Shift DX. So the reality of agriculture in the world currently is that we need to supply an increasing number of people around the world. Agriculture is specifically under pressure with regards to the natural resources that we use, like water, and we need to be more sustainable in the way that we produce food. The world population is going to grow with 30% over the next 30 years, and we will have to do more with less resources.
Guys, I just want to make sure you see the video and you hear everything.
All good, Sean.
Okay, great. Thank you.
Over the past 2 years, we've invested a lot of time, a lot of effort, and a lot of money in developing a full provenance and traceability dashboard that is backed by blockchain technology. Blockchain enhances the trust of the total value system. That's something that's really important for us in our industry, that we believe that we need to do something more ethically, more responsible, and a more trustworthy way. And we formed this relationship with ARKTREE and specifically Sean. We then started looking at the capabilities and the use cases for blockchain.
Where Shift is effectively providing a solution for various actors to participate with each other in a manner which is traceable and trustworthy. What ARKTREE does is it enables the back end of that using what we refer to as nodes. Each node is an independent record of truth, effectively some type of ledger, if you'd like to call it that. And it's not in the control of any of the entities or the actors that are participating. It's ARKTREE's responsibility to ensure autonomy, such that there is accountability and transparency regardless of any potentially underhanded behavior within that consortium or network of actors.
So there's various value chain actors in this process. We've got BKB as the broker, we've got the buyers, we've got the shippers, we've got the processors. All of them are playing a role together with the farmer and the transporters. As wool are delivered at BKB, it is collected and a RFID tag is assigned to the bale. As you can see, a lot of information is collected on the wool lot. In the blockchain, we see the wool lot as a unit of value. Through the use of RFID technology, we are turning a physical wool bale into a digital wool bale. As the wool bale are passing through the processes at BKB, information are collected on various systems, which are then recorded on the blockchain as events. These events are recorded as receiving, the sale at the auction, the ordering process, the shipping, as well as the packaging. Through the value chain, you can see how these products are moved from location, changes in ownership, changes in quality, changes in processing. All has been recorded in a trustworthy way for the end user then to eventually see that they did get a product that was ethically sourced, sustainably sourced, and has an element of trust to it.
All right, so the point of that video is to show you that whilst we have all of these different devices available, until we find a way to connect them together, automation is going to be limited by its ability to interoperate with whatever other devices and whatever other technologies in that supply chain or in that system. I'm going to give one more example in livestock, and then I'm going to come back to the point of where is automation evolving to. So in the livestock game, the types of things that we're busy with at the moment are, for instance, where you've got the XR5000 device, which is an all-in-one weigh, scale, and data recording machine that effectively allows you to record events that are relevant to the farm and to the downward supply chain that effectively cares about those events, such things as the registration of the animal using an electronic ID identified by an RFID tag, the weight of the animal, which needs to be measured almost daily, whether it's gone through its, the vaccination programs and compliance with those vaccination programs that are required, to ensure that it's of a certain standard for a particular market, what its feeding programs are like, and essentially getting it ready for sale. So there's often, the use of Internet of Things here, there's the use of mobile, there's the use of big data, there's the use of cloud, RFID, etc., etc. And we need to start using all of this technology together in a way that all the different actors in the supply chain, not just the farmer, but also the brokers and the buyers and the transporters and the auctioneers and the shippers and essentially the importers, etc., are all able to participate in one digital thread of truth across this automatic supply chain. And what we can achieve here through this is we can essentially bring in this notion that previously we could finance and insure commodities based on the asset value of the owner of the commodity. So the land value of the farm is an example. What's going to happen now is that with the automation of data across the supply chain, rather than the automation of simply looking at it as devices, the commodity of value here is the data. And by providing a trusted digital thread of data automatically from source to target across an infinite number of devices if need be, in a way that it's not so important what device is being automated, but it's important that the device can be trusted and that it can interconnect and interoperate with whatever's on its left-hand side and whatever's on its right-hand side. By doing that, you can tokenize the information. By tokenizing the information, you remove the value of the proposition or this marketplace. You remove the value of that from that of the farmer and his land, and you shift it to that of the commodity in question. So it could be livestock. You also allow for the inclusion of micro farmers to participate in a macro market, because if they can meet the right standards of quality through associations that aggregate their product into an already established marketplace via technology that we can trust is providing us with trusted data and certifications and compliance programs, etc., then suddenly this token becomes something that is of worth in the digital landscape, and it becomes virtually scarce. In other words, it's as scarce in the virtual landscape as it is in the real one. And now we can open up new business models which allow us to say, all right, well, I can now finance this using crowdfunding. I don't need a bank. Or I can insure this because I can trust that the quality of the commodity is perfectly intact with this season, regardless of the financial state of the owner of that commodity at that point in time. And that's the sort of power behind the technology that we're speaking about. Now, taking it back to wrap it up, right? We saw that we had this idea of fixed automation, programmable automation, and flexible automation. And the question is, where is it evolving to? And Gartner is sort of saying that there isn't any one tool, one device, one process, one anything that's going to allow us to advance automation or allow it to evolve or become what it's capable of becoming. But there is this concept of hyper automation, which is in the top 10 strategic objectives according to Gartner companies today. And in order to achieve this hyper automation, where we do bring the tools and the technologies and all of the techniques together to amplify the ability of this to automate more processes across a global supply chain that's interconnected, interoperable, but still needs to be trusted, and bringing together all these different technologies that have got all their different automative capabilities, we need one underlying digital thread that puts it all together. And that's where I say that the distributed ledger system of trust is an answer to bring everything together in a way that we can all trust, and we don't have to worry about that interoperability. And we get to the point where in the olden days when we had all these different plugs and we had to have these adapters, etc., we're now starting to find a uniform standard of technology that allows us to plug and play with many different devices as if they were all part of the same standard across a global system where everybody trusts everything. And then we can achieve what is referred to as the evolution of automation being hyper automation. And that's the pitch. So I hope that makes sense. And if not, please shout. I'm ready for any questions that you might have.
Thank you, Sean. It's a very insightful session.
Thanks, JD.
Just wanted to find out, did you have you done any implementations or projects within the fruit industry?
Not within, but we are actually in discussion with, so ShiftDX is having discussions with the fruit industry currently, and where one of the challenges with the fruit industry is ensuring that the container shipping process is well integrated, and that's part of what we're busy addressing at the moment. So we're moving toward the fruit industry currently. Yes, it's part of our agenda.
Okay, good. It would be good to have maybe a follow-up or breakout session with regards to that, specifically to the fruit industry. We do have some backhouse technologies and also RFID out in the field fruit industry, and open to collaborate for the hyper automation.
Great, that would be great. I'll move across to the breakout session once this is over, when everyone's happy that they haven't got any more questions, and then we can chat. So guys, what do you think? Does this concept of, if you think of the limitations of technology being that they might be competing with each other, and if we can find a way for technology to become somewhat agnostic regardless of the device by virtue of another layer that puts it all together, and doesn't only put it all together in a technological framework, but puts it together in a process framework, in a trust framework, covering more than just technology, but in fact political and economical and social and technological and environmental and legal factors in conjunction with technological automation and integration across entire supply chains. Suddenly we can see that synergy is possible, where in the past we would have seen it as a threat to our business. We can now see that we can in fact elevate everything that we do, because even our competitors can share the platform without us losing a competitive advantage because of the cryptographic nature of what lies beneath, ensuring that only what should be seen is seen, and what shouldn't be seen is not, and what should be transparent is, and what shouldn't be isn't. And so suddenly you can leverage that capability and get out of the way of yourself with your own technology.
Just a quick question, and apologies if it comes from ignorance, but on a principle and even a philosophical level, it makes a lot of sense. But you know, from a complete ignoramus point of view, what does the back end look like? I mean, what are the gears and levers behind the process? And I'm thinking at it specifically from a spend and investment point of view. To make a business case or something like that, where would one start?
So basically, at first I want to say that wherever there's a technology in use that works for you, the intention is not to eliminate it, right? Of course, if the technology is expensive and there are cheaper alternatives, then that can be discussed. We talk about digital transformation, and we understand the full stack of technology and how it integrates with all other technologies. We use open API technology, and the base of our technology is a product called Fracta. And you know, SYSPRO and ARKTREE are working together to essentially bring Fracta into an existing technology stack, into an existing enterprise architecture. And what Fracta does is it uses open API technology, which integrates as a service. So in terms of the investment that you speak of, it's really a monthly subscription fee. It's software as a service, but we refer to it as blockchain as a service. It has a very low cost of entry, because we can integrate with whatever technology is already there. And by doing so, we are able to feed the information from the different sources for that particular stakeholder in the supply chain at a very low cost. By doing that, the way we enable trust across the network of all the different supply chain actors in your ecosystem is we distribute what we call nodes. And what they do is they ensure that you have a record of the information, and so does another actor in your supply chain, and so does somebody completely independent of you, so that there can't be any collusion. And what the effect of that philosophically is that we know that we can trust the system because no one actor in the supply chain is able to alter the state of record. What we're seeing is that in Europe, for instance, this is becoming a demand item. So consumers are starting to say, I want traceability, I want proof of sustainability, I want proof of ethical handling of animals or whatever it is, ethical labor. I want to know that the certificate that you're issuing that says that this rhino horn is an authentic rhino horn and that it was handled in an ethical manner and that it isn't part of a black market. Otherwise, forget it, I'm not interested. And the only way that we do that is by using a technology that everybody can see and share in, whilst keeping any trade secrets cryptographically secure, and then making sure that everyone has a record of that ledger that is a stakeholder, an interested party in the supply chain. So we don't go and build completely new systems for you. All we do is we take our network system, we distribute it further with more agnostic trust anchors in that network, and then we plug you into it at a subscription cost.
Excellent, thanks. It brings some other interesting questions about applications on a maybe more statutory level, but I mean, that's a topic for another discussion, but yeah, really exciting
So
stuff.
I'll give you some, it's just something we've just done is we just tendered for a piece of work with the industry governing body of wool in South Africa, Cape Wools, and we were up against some pretty big hitters globally, and they report to the Department of Agriculture. So it's very interesting because we're starting to see that government, even in healthcare, we're seeing the same thing. Government and the Digital 4IR initiative is starting to acknowledge that this type of technology is required. And so when it comes to the governance, we spoke about ethical justice systems, and by virtue of applying something like a smart contract, we can ensure that based on X, Y, and Z events taking place, dependencies being met, A, B, and C will definitely happen, and it will happen automatically without any human intervention, so that we can trust the system absolutely and reach a state of trustlessness. So that application will come through in various ways, shapes, and forms. And one example of that, for instance, could be voting, democratic voting. If we know that I've got a digital ID and I'm making my vote remotely, I don't even have to be present because my digital ID is as scarce online as it is physically. Then when I make a vote and it's cryptographically secure, nobody else can actually see it. But I know that with zero knowledge proof, i.e. without knowing the specifics of it, I have proof of the outcome. I know that my vote will go to whatever ballot I set, and I know that the outcome will be democratic. So those are the types of things that this technology enables, but it's got a wide range of applications across every single industry. And Agri is, in fact, where we are focusing at this stage to prove the value of the technology.
Sean, I'm curious about the interface and the different data limitations to specific register or specific nodes in the chain, what they can see and what's limited. The interface, is it varying for different users? I did see a bit on the video. I'm just curious about that.
Yes, so what we do is we talk about hybrid blockchains and hybrid distributed ledger systems. And what we do is we've got a non-permissioned chain, we've got a consortium permissioned chain, and we've got a private chain. That all happens within the same network, but what we do is we differentiate by virtue of channels. And so the technology allows you to say, when I pass information through this API, I'm going to indicate that this information is for public view, which means anyone can go to the website, they can click the link, they can see the event, and they are able to, without any authentication, verify that it is absolutely true and immutable meaning unchangeable and with absolute accountability. It is absolutely true that this agri product came from that source, was ethically farmed, and went through all the certification standards that I'm buying. That's a non-permissioned level of authentication and visibility. What then happens is you get consortium access, which is where a bunch of guys that collaborate together in a supply chain want to, and this is all, by the way, this is all layered in the same system. So it's not like they're mutually exclusive. It's all happening at the same time on the same platform. but essentially what happens there is they have access, so they have authentication. With their authentication, once logged in, they're able to see certain information in that network, and then you get a third, more concrete level of security or cybersecurity, which is a cryptographic private data collection. And what this does is it says when you pass certain information, call it like the R&D information for a bill of material or recipe for a new product that you're about to launch and you don't want anyone to know and you still need to register an IP and everything. There you use a private data collection, and what that does is it says I'm only allowing that one person or these three people to see this information, and everyone else in this network, there can be thousands, hundreds, tens, whatever, no one else can see it because they don't have the key to the information and it's cryptographically secure. So the varying levels of privacy, security, and also transparency are all fit for purpose in accordance with the use case of the data and what it's purposed for and how secure it needs to be in an appropriate manner. The technology enables all of that. Which is why we talk about co-opetition, where competition can collaborate with each other. They can cooperate with each other because there's no risk of a security breach.
I'm curious about the non-automated input. So if there's a user input and how that's validated, or can a mistake, for example, be rectified and validated?
Yes, it can. So there's a misconception in the world where they think because the word immutable is stated, it implies that it's unchangeable. And whilst that's true, it is unchangeable, it can be revised, and it gets revised with exactly that. We call it a revision. So if a mistake is made or a mistruth is posted and needs to be corrected or amended, then what happens is another API pass of the data goes in with a correction and a revision is logged. So that means that you see what was first posted as incorrect, but the latest event shows that it is now corrected, and that is the state of truth, and everyone will know that the revision was in place to adjust for that mistruth. So that's one element of it. In terms of manual, because we're really technology agnostic, we don't mind what the source of the data is. It can be a system, so we can directly automate the API integration with a system like SYSPRO, or we can provide, and we do provide, for instance, for the wool buyers, we have a platform that allows them to log on to a web-based platform, upload certificates, run through certain checks and controls for the shipments where they know that certain documentation needs to be loaded, and until it's all loaded, they can't hit the send button. Once they do, that documentation actually gets hashed. It gets passed to the blockchain ledger. That ledger is then a reference of that document, which means we don't need to load the document itself. We need to load a reference of the document, which is using a cryptographic hash. And what that means is that if anyone alters anything somewhere in the conventional technology, the hash is immutable and unalterable. And so when we rehash the item, if there's an audit, and we rehash the item subsequently and it doesn't come out with the same hash key, we know that then foul play or something has happened and there's a clash and there's a conflict and now there's an audit action. So that we get around large data volumes on blockchain by simply hashing the item, passing a 32 or 64 digit character to the ledger, and ensuring that we can check it against that for future audit. In terms of the manual input, you can use an upload from Excel. You can use a mobile app. You can use a web-based platform. You know, any conventional way of inputting information today can be done with an interface to our distributed ledger API. And if there's certain checks that you need to make in order to, before you commit the data, so say you want to check that it's within a tolerance, that it makes sense, that the data is not nonsense, then you put in a rules and alerts engine logic. So an application logic which filters out or checks before it allows for a commit to the ledger. And all of that stuff is the types of things that we do. Does that make sense?
That makes sense. Yeah, thanks, Sean. I was just seeing if there's any other questions. I'm curious also about the global audits, like Global Gap and so forth, or they're very open to collaborate, or is it what's your perspective on that?
Very open to collaborate. So we, for instance, in this wool industry now, we've had several conversations with the International Wool Trade Organization. We've had conversations with the IMF, with UNICE, with all these regulatory and compliance industry governing bodies are absolutely interested in this technology because it's the first time they've got a way to ensure without any doubt that everyone is going to follow a certain standard that they are trying to uphold across a global and very complex supply chain. So they're very pro the technology.
Okay, that's good, because I know on a lot of the farms the audit is becoming quite extensive, and a lot of the inputs to the audit is very manual. But it's good to hear that.
Yeah. So in fact, what's happening at the moment is, because we won the account for the industry governing body of South Africa, that body is actually currently speaking to the equivalent industry body in Australia. And it looks likely that they will also want to participate because they see the merits of the technology.
Maybe just a quick last question. Obviously, the privacy and exclusivity is a given, but have you had any questions as far as POPIA and GDPR has been concerned? I mean, are those specific issues that is addressed, or is that just part of a bigger conversation?
It's part of the bigger conversation, although it's not an issue to us. So if you're storing information inside of a cloud database, and you've got your standard VM with all of the AWS or Azure-based security, which provides for protection in the context of POPI and GDPR, etc. And there are GDPR APIs that also can be applied to sensitive data. Then essentially we're doing exactly the same thing at a distributed level. So we're applying exactly the same standards that are being applied today in the context of POPI and GDPR, except we're applying it to a distributed ledger system. So it's very much fitting in whatever's there to this new concept.
Excellent, thanks.
Sure. Good questions, guys. Good questions.
Maybe a last one if we've got some time. I'm curious about the end user. How do the interface for the end user and how he interacts with the data or feedback to the different nodes?
Yeah, so basically the end user sees a dashboard, and an example of what we've built in the wool game is that we allow the business that's passing the data to tag their information. So for every post, there's what's called a document ID, and associated with a document ID is a tag. When they go into either they log in or it's a non-permissioned, it depends on that. You get public and private data. So if it's public data, they can just put in their search tag, and it will bring up everything associated with that commodity. So this talks to the concept of upward and downward traceability. Effectively, what you're doing is you're saying, I've got this document ID, and it's now going to collect everything about this commodity, no matter what happens to this commodity from this point on. And the first event is, for instance, a wool receiving event. And the moment it then goes to the warehouse, there's another event. And then it goes off to quality control, and there's another event. All of those events are stored with different tags, but against the same document ID. At some point, it will sit inside of a shipment or a container with a lot of other commodities and lots as well. Cheers, Vota. And it will form part of a shipment. But what happens is that when you go into the shipment, you can see the individual lots or the individual batches and their specific IDs. And then you can, in fact, drill back down from there back to the source event at the farm. And so the user is able to use this dashboard by putting in search criteria, finding all the related documents and then analyzing those accordingly. What the opportunity is to say, well, once all the data is collected and we know that it's trusted and that it's all connected to every event across the supply chain, no matter where it is in the world, now we've got opportunities for true analytics, and that's where the user interface will probably evolve toward, where more advanced analytics tools will use this distributed ledger as the source of that data, because we know it can be trusted and we know that it's connected upwards and downwards and fully traceable.